Hello, I'm John here from Accu-Slice. In this video series I'll be describing the complete design, assembly, and alignment of the Accu-Slice Index Table. The content of this video will not only be informative, showing you how we assemble and align the Accu-Slice system, but can serve as a guide for you should you ever need to service, realign, or modify your Accu-Slice system. This first video will describe the historical development of the Accu-Slice system and also describe the complete assembly of the Accu-Slice Index Table. I originally came up with the concept for the Accu-Slice system about 10 years ago. My original purpose was to make it safer when slicing thin boards on the bandsaw. At that time I was producing some thin cherry wood veneers for an entertainment center that I was designing and building. In cutting the 1/16 inch thick veneers, my fingers were less than half an inch from the bandsaw blade, and this made me quite nervous. Therefore I developed my first version of the Accu-Slice system. This first prototype version, produced in 2013, was mounted on my original jet bandsaw. The boards to be sliced were screwed into an L bracket plate that used two aluminum guides that slid into two T-slot channel rails. The entire assembly was attached to the bandsaw table with some aluminum sidebars that were screwed into the side edges of the bandsaw table. This version worked quite well to produce these thin veneers that I needed for the entertainment center I was building. This is the finished entertainment center. The majority of this project was constructed from solid cherry wood, but I used a 16th inch thick cherry veneers to design and build the inlaid countertops for the main countertop and also for the pull-out side tables that were built into the system. Over the next 3 years, I made a number of revisions and improvements to my Accu-Slice system design. This is the second improved version of the Accu-Slice system. In this version, I used a larger rail and I added a mag jig clamp. I then took a final third version of the system to a team of engineers and machinists at Scientific Instrument Services, who reviewed the design and helped develop subsequent Accu-Slice system designs. This is a list of the team of engineers and machinists I assembled who were instrumental in designing, machining, and producing a large number of improvements to the Accu-Slice system. I could not have developed the Accu-Slice system as you see today without the input of this team of machinists and engineers. In particular, two machinists, Daniel and Tom, who each has more than 20 years of machining and tool and die making experience, are responsible for many of the design improvements to the Accu-Slice system. This is a list of design improvements made to the Accu-Slice system. I'll now review each of these major improvements to the system. The Accu-Slice system mounts into the bandsaw table using a miter bar with 3 locking clamps. The rotating indexer with 1,000 inch increments was a major addition to the Accu-Slice system and enables the adjustment of the thickness of the board to be sliced. The 2 guide bars with linear bearings permits the smooth adjustment of the index tables. The adjustable mag jig clamps permit the attachment of the Accu-Slice system to a wide range of bandsaw sizes. The custom designed and extruded Accu-Slice rails are light in weight but quite strong due to their unique structural design. The various Accu-Slice carriages all use our adjustable custom designed roller bearings with stainless steel roller bearings with polycarbonate sleeves for the smooth travel of the carriages on the rail. Over the past 7 years, we've continued to improve the design of the Accu-Slice system. At one point, we actually had 9 models of the Accu-Slice system to fit the various bandsaws on the market. With some additional design improvements to the Accu-Slice system and the addition of the adjustable mag jig clamps, this has now been reduced down to 2 models, which fit most of the bandsaws currently on the market. These are all the components needed to assemble an Accu-Slice system. The Accu-Slice Index Table is comprised of 34 precision machine parts and more than 30 additional parts including screws, snap locking rings, thumb screws, and several alignment or locking pins. These precision machine components enable the accuracy and adjustability of the system, but they're also the reason for the cost of the Accu-Slice system. This main plate for the Accu-Slice system is made from 1/4 inch thick aluminum sheets. As a result, the finished assembled system is quite heavy, very strong, and very accurate. Using the Accu-Slice system, I've been able to slice boards down to 5,000 inch thick and to an accuracy of 1 to 2,000ths of an inch. All the machine components for the Accu-Slice system are machined in the U.S. either by myself, in my shop, or outsourced to local machine shops that have greater machining capabilities than I have in my shop. I have produced a number of videos demonstrating the machining of these components in my shop, which will be referenced in this video and listed in the description in this video below. In the remainder of this video, I'll demonstrate the complete assembly of all these components to produce a finished Accu-Slice Index Table. In the second part of this video, I'll be demonstrating the alignment of the index table and describe troubleshooting the system to correct any potential problems and improve the performance of the index table. The description of this section might prove useful to you should you ever need to repair your index table, realign your Accu-Slice index table, or make any of your own revision to the system in the future. I will also compile a list of possible replacement or service parts which are currently available. In this section of the video, I'll show how the various parts are assembled to produce the Accu-Slice Index assembly. There are a total of 11 parts including screws, washers, snap rings, brass turnings, the housing, an index knob, and the end blocks, which are used in the Accu-Slice Index assembly. A 1/4 inch left-hand screw was previously screwed into the brass bearing and glued in place with Loctite. A small amount of fine oil was added to the screw, and the screw with the brass bearing is screwed into the larger brass bushing. This assembly is then inserted into the block housing. A wave washer and brass bushing are then added along with a small amount of oil, and then is held in place with a snap ring. A YouTube video describing the machining of some of the components for the indexer is listed in the description section below. The index knob, which has 1,000 inch calibration marks, is then attached to the brass bearing and secured in place with a small set screw. The end block is then attached to the opposite end of the assembly and held in place with a small flathead screw. And that completes the assembly of the Accu-Slice Index assembly. There's two sizes of linear bearings for the Accu-Slice system. The shorter bearing, which goes in the front bar on the Accu-Slice system, and this longer linear bearing, which goes on the main plate on the Accu-Slice system. The front linear bearing has a insert, and it's held in place with a snap ring, and the longer bearing has a longer bearing that goes completely through the block and held in place with two snap rings. This front bearing consists of a precision machined aluminum block. This aluminum block is precision machined. This holds is a very, very tight fit to the bearing, such that it actually has to be press fit in place with a press, then held in place with a snap ring. The longer front bearing again has a hole, again precision machined, goes completely through the block. This bearing will slide completely into the system and then held in place with two snap rings, one on each end. The aluminum block for the main plate bearing is placed on top of a wood block on the arbor press. This wood block has a recessed hole of the correct depth for the linear bearing. The arbor press is then used to force press the 12mm linear bearing into the precision drilled hole in the aluminum block. Two 21mm OD snap rings, one on each side of the linear bearing, are attached to the linear bearing to hold it in place. The two snap rings lock in place into two grooves on the outside of the linear bearing. And this is the completely assembled linear bearing for the main plate on the Accu-Slice system. This block for this front linear bearing has an inside groove, and so this bearing has to sit below that groove. That's why when I press fit it in, I use this spacer here to push it down the whole way to make sure it's below that groove, and then the snap ring will snap it and hold it in place. So there it's held in place, and on top of this linear bearing there's two holes. These are the mounting holes that screw this to the front bar, and this hole here is a 1/4 inch diameter where a brass pin will go in there, and that's the locking system to lock the carriage in place on the linear guide bars. And these are the completed linear bearings with holders for the Accu-Slice system. The miter bar for the Accu-Slice system consists of a 3/4 inch wide by 3/8 inch thick aluminum bar with 3 milled slots in the center of the bar, and then 2 pinholes and a countersink on each end of the bar. In the center of each of these milled slots, a small hole has been drilled into the miter bar for the press fitting of this brass offset cam nut. In each of these milled slots, an aluminum miter bar cam lock will be inserted. This cam lock slides back and forth in the milled slot. In the center of each of these miter bar cam locks, This brass offset cam lock is press fit into the center hole in the miter bar. As this brass offset cam nut is then rotated, this is what slides this clamp back and forth. And this is what actually clamps the miter bar into the miter bar slot on the bandsaw table. It's important in rotating these brass offset cam nuts that you do not over tighten them. If you do so, you will cause premature wear on these brass offset cam nuts, and they will need to be replaced. Normally they should last a lifetime unless they're over tightened. They can easily be replaced by using a punch to remove the old offset cam nut and then insert a new offset brass cam nut as shown in this video. To install these pieces into the miter bar, I first of all position this aluminum sliding piece in the milled slot and then place my brass cam nut in the center, aligning it with the hole in the miter bar. Then I usually use a plastic hammer to just lightly tap it to position it in place. Then I'll put this on the press and press it in place. I usually place a paper over the surface just to mark the surface of the brass cam nut and push it down to lock it in place. In a likewise manner, I insert the aluminum miter bar cam lock into each of the milled slots in the miter bar. Then insert the brass offset cam nuts in the center of the hole and use the arbor press to force the brass offset cam nut into the hole in the miter bar. And this is a completed miter bar with the 3 miter bar locking assemblies installed. It is important that the cam lock and the brass offset cam are below the top surface of the miter bar. Otherwise it might scratch the table on the Accu-Slice system. So they should be below the surface. And here you can see the process of rotating the cam, moves that aluminum piece back and forth. A small amount, just enough to lock it in place in the miter bar on the bandsaw table. Now it is important you don't over tighten these brass offset cam nuts. If you over tighten these too much, you can actually damage the offset brass cam nut. But they can be replaced. They are replaced by taking a punch, punching it out from the back side, and then inserting a new brass offset cam nut as shown in this video. The Accu-Slice uses a series of alignment pins for the installation of the various components of the Accu-Slice system. And the first 2 pins are these 1/4 inch diameter pins which go in these 2 holes on this main plate on the Accu-Slice system. And these are for the rail for the Accu-Slice system. So these 2 pins align the rail, and these 3 holes are tapped, and the rail screws into those holes to hold it in place. But these are just alignment pins. So those are 2 pins that go there. Back here, 2 1/8 inch diameter pins are inserted, and these are for the indexer. So it aligns the indexer so it's properly aligned. So the way these are installed, I usually take a pin and just lightly tap it in place to get it somewhat aligned. And then I'll press it firmly in place with my press. So there's one. It's not in far, just enough to hold it in place till I press it firmly in place with my press. And these pins are pressed into the plate just through the plate, not beyond the bottom of the plate. If the pins extend beyond the bottom of the plate, they'll scratch the table on the bandsaw. So you do not want these pins going beyond the bottom of the plate. And then once those 2 pins have been somewhat aligned under the plate, I then use my press to firmly press them in place. As you can see, the pins are a very tight fit, and it takes quite a bit of pressure to force the pins into the holes. But that holds them in place permanently so they don't move. And those 2 pins went through, but they're not beyond the bottom of the plate. As I mentioned earlier, if they go beyond the bottom of the plate, they'll actually scratch the table on your bandsaw. So if you have a table or an index system and these pins are extruded beyond the bottom, just take a small ball peen hammer and tap them down a little bit so they go beyond the surface. Next, I do the same thing on these 2 pins to get them aligned. I usually use a pair of tweezers just to hold them. My fingers are too big. thing. I take them over to my press and press them in place once again. Again, making sure the pins don't go below the bottom of the plate. Again, they're pressed down the whole way, but they're not beyond the bottom of the plate. The other place alignment pins are used are in these guide bars for the Accu-Slice system. And these are 2 pins that go in these 2 small holes in the blocks on the end of the guide bars. And usually they go in finger tight. If not, you can always tap them down with a hammer, but usually they go in finger tight. And this is what holds the miter bar in place, the lines of the miter bar in the Accu-Slice system. So those pins there align with the pins here in the miter bar, and then it's screwed down in place later on. These pins actually align the miter bar square to both side guide bars. And here's a close-up view of the 2 pins inserted in the blocks at the end of the guide bars. Next we'll go through the assembly of the 2 guide bars, the miter bar and the front supporting bar. And that's where these pins are used in these guide bars. They align with the pins in the miter bar. So what I know how to do is I get these aligned at the line with the 2 holes in the guide bar. And then use a small hammer just to tap it in place. And I do that on both ends. As mentioned earlier, these pins actually align the miter bar square to both of the side guide bars. So next I install into your bearings. The long one goes on first, both ends. And then the smaller one goes on next with the pin facing up towards the top. And then this front bar goes on next. And there's 2 set screws in the end to hold that in place. I usually align those at just the guide bar goes completely through the front bar, and then they're locked in place with the Allen drive-in set screw. I do that on both ends. And now this is ready for the installation of the front table and the back bar. In order to lock the miter bar to the guide bars, a flathead screw is then screwed into the miter bar, and that's tightened down tight. Now, one critical thing to make sure is that this screw is below the surface of this guide bar. If it's above the surface, it could scrape the bottom of your Accu-Slice system. So I try and keep that either flush or below the surface of the miter bar. And you can always increase the depth of the set screw hole or sand off the top of the screw. And I repeat that on the other side also. If you're getting scratches in the bottom of your Accu-Slice index table, this is one area to check. Make sure that these screws are not above that miter bar, because that can scrape the bottom of the index table. And again, that's below the surface of the miter bar. Okay, now we're ready to complete the installation of the components. Now we've got our frame all assembled, and the important things are making sure these are below the top surface of the miter bar, as are these below the surface. And these indexers or offset clamps should be facing towards the inside, not the outside. So the first thing is to install the main table. And that installs with 2 screws on each of these blocks. table is screwed into 2 holes in each of the linear bearings. And these screws I'm just tightening finger tight because they'll be removed later when I do the alignment. So these are all just finger tight for now. Later when we do the alignment, we'll be removing these screws and putting some Loctite in the hole to get them down nice and tight. And we install the front bar. First thing we do is put these brass pins in. Now these pins have an orientation. There's a curved portion on it, and that goes down across the bar because that's just going to seat against this round bar. So that round surface goes down. That's on both sides. And our front bar goes on. And again, that's held with 2 more screws. And again, just finger tight on these. No need to tighten down right now. The next part is the indexer. Here's our indexer, and there's 2 pins here on this plate. Those go into 2 pin holes on the bottom of this indexer. So let's go down and get pushed down tight. Then I turn this upside down and install the screws to hold that in place. These are a slightly shorter screw. Now these 2 on the main plate do get tightened down tight. So the 2 screws with the 2 pinholes are down tight. And the second bar gets aligned to the front part of the indexer. And these are kind of loose now. This actually moves now. Later when we tighten those down, it'll become permanently stiff once I tighten it down. But I'm not going to tighten down until we actually put it on the bandsaw for alignment. Okay, turn it right side up again. And the next step are the mag jig clamps. There's 2 sides of the plates here, one with screws in it that goes on the bottom, and 2 with through holes that goes on here. Now these mag jig clamps go under, there's a screw with some washers. And those washers can be adjusted, removed, added to, depending on what length you need. But basically, I put the screws through the mag jig clamp, put 2 spacers, put the plate with through holes, and this slides in the slot on the top. And this bottom one goes underneath. That's what clamps it in place. The position of the mag jig clamps is critical. If they go down too far, they'll scratch the table on the bandsaw. If they do not go down far enough, they will not clamp into the bandsaw table. The black Delrin spacers are precision machined to the correct length to position these mag jigs correctly. However, if necessary, they can be adjusted by changing the length of the Delrin spacers. Now these were designed such that these mag jigs can be moved back and forth. And again, this is for different size bandsaws. You want to make sure that, first of all, it doesn't interfere with the miter bar slot on your bandsaw, but you can adjust it for larger or smaller bandsaws. Typically on most bandsaws, it just goes in the near front position. I mentioned these washers can be added or removed. The main thing here is the screws do not go through that plate. Again, you don't want anything going beyond the bottom of the plate. So if those screws are too long, you have to add washers. Another option would be to grind down the length of the screws. And likewise, we add the second mag jig clamps. Again, 2 washers. Plate with the through holes. And then lock it in place with the bottom plate. see there that bottom plate, this is recessed. So this bottom plate is again below the surface of this plate. So these are all recessed plates here. Just to summarize it, nothing should go beyond the bottom surface of this main plate. That includes screws, pins, or the mag G clamps themselves. And the last thing are 2 thumb screws, and these lock into those brass pins that we put in that front block. And that completes the installation of all the parts for the Accu-Slice system. And the next thing will be to put this on the bandsaw in alignment. This concludes part 1 of this video series, which described the history of the development of the Accu-Slice system and also described in some detail the actual assembly of the Accu-Slice Index Table. I hope you found this video informative. In the description below, I've listed the other videos in this YouTube video series in which I describe the various machining operations to machine the various components using the Accu-Slice Index Table. Once again, thank you for watching this video. If you have any questions or comments, as always, please give us a call or drop us an email. Part 2 of this video series will be available in about 1 week. In this Part 2 video, I'll be demonstrating the alignment of the index table on the bandsaw and describe troubleshooting the system to correct any potential problems and to improve the performance of the index table. If you currently have an Accu-Slice system and are experiencing any issues such as scraping on the index table of your bandsaw, the information provided in this video can help resolve these issues. The details described in Part 2 will also prove useful should you need to repair your index table, realign your Accu-Slice system, or make any revisions to the system in the future. In this video, I also compiled a list of replacement and service parts which are currently available. And once again, thank you for watching this video.